Hello everyone and welcome to day 3. Today we are going to make a very interesting project where you will design your own personal robot. So to begin with, we of course start with the most important component, which is the microbit. I will just type in microbit. And you can see over here that we have two microbits, one with a breakout and one is the regular microbit that we've been using so far. I'm going to drag both of them. And then we will need a breadboard. All we need to have is this one, a simple breadboard. Now, we need a power supply. There we have our power supply. So I'm dragging each and every component. And eventually, we're going to need a servo motor. There we go. We are going to use 4 of them. So to accommodate four legs or 4 joints, whatever you want to imagine the robot to look like. Or wheels, it is completely up to you. And then we are going to start connecting. Now, let's start with the first one. The first one, we are not going to connect it with anything because we want it to communicate with the second microbit wirelessly. This is why we're not going to connect any wires to the first microbit, but we are going to program it. The second microbit has a breakout. What does this mean? If you notice over here, the microbit in general has only 3 pins, 0, 1, and 2. Then you have the 3 volt and the ground. The microbit with the breakout will give you more pins where you can just try to add much more components to your microbit and to control them. So this is why it's very important to have a breakout. Now, let's connect the microbit or the breakout with the breadboard. Now, I need you to notice how the first ground highlights when we are connecting it to the breadboard. I'm going to get it closer. And there you can see that it is highlighted. So I release it. That means it is connected. And of course, all of these are connected together. All of this line of nodes is connected together. So whatever we connect here is connected to the ground, whatever is connected here, it's connected to P0, and so on and so forth. Now, let's move on and connect the power supply. It is pretty easy. The power supply that we have has a negative and a positive pin or a part. So the negative, we are going to connect it to over here. You can see that we have the negative sign. So we're going to adjust it to make it look very tidy and clean. Normally, we put the negative with the black color. So this is the wire type. And then if you want to choose the color, you put black. Then for the positive, you can see over here we have the positive. So we connect it this way. And again, we try to fix it to make it look clean and nice. So we put it as red. Moreover, when we click on the power supply, you will see, let us just zoom out. When you click on the power supply, you will see the name of the power supply. You will see the voltage and the current. So far, the voltage and the current, we put it as 5. We can put a small note here just to explain that we set the power supply voltage to match the components. So what does this mean? We need to check what the components, how much power or voltage do the components need, and this is how we decide what our power will be, and of course we change that using the voltage and current. Okay, moving on, we are making sure that the positive is connected to the positive of this side and the negative is connected to the negative of this side. So I'm just going to take a wire from here, red wire, make sure not to connect it anywhere here. I'm gonna take it out, then go down and connect it to there, the positive. So now I'm sure that the positive here is connected to the positive here. Let's connect the negative. There we go. So we connected the negative as well. Okay, now we will start connecting the breakout or the microbit. So first of all, you can see over here that we have the ground. So we are going to connect the first ground with a negative wire or with a black wire. Make sure not to connect it to any pin, and it has to be something that is within this line. So we make sure it is connected to the ground, as you can see over here. Okay, moving on, we will start connecting the micro servo. So you can see already that the micro servo is it has 3 pins. First of all, let us decide what our servos will be. What is the functionality of our servos? So I'm going to put some notes. So this servo is left leg A, for example, and then I'll have another servo which is left leg B, and then another servo which is right leg A, and then another servo which is right leg B. So what does this mean? Let me just write it correctly. This means that I am creating a robot that is walking on 2 legs, but these legs have 2 motors. So I have A and B. Okay, now what are the pins of the servo motor? You can see that we have the ground, we have the power, and we have the signal. Okay, so let's start with the ground. The ground is black. You connect it to the line of the ground or the negative power supply, and we do the same for all of the motors. There we go. Make sure you connect it to the right line. There we go. Okay, now we are going to connect the power. Red power to the red line. There we go. And here we connected both the power and the ground. Okay, now let us decide which pins are we going to use for the third pin, which is the signal. For leg A, we are going, let us choose the color green and connect the signal to pin 2. Over here, I'm going to go all the way to pin 2. There we go. Okay, now what about the other one? We are already leg B for the left side, we are going to connect it to pin 8. Let's move over here. Okay, so we connected both leg A and leg B. Let's then move to the right leg signal. We are going to connect it to pin 14. Okay, let's put it a bit down. Over here like this. And then we are going to connect the last signal pin of the right leg B to 16. Pin 16. Here we go, and let's connect it to 16. So now we have 4 servo motors that are connected. Each and every pin is connected in the right place. We have the breakout. The ground is connected, and all the pins that are needed is connected as well. We have the positive is connected to the positive, the negative is connected to the negative, and the power supply is connected as well. And that should be enough for the basic circuit of our project. Okay, so now we are going to program our robot. So to begin with, we are going to program the simple one, which is the microbit over here. And our aim is to transmit certain signals. So how can we do that? We'll go to code, and from code, we will choose, of course, on start. And then we will add something new, which is radio set group 1. What does that mean? If you are within this group, the set group, and you choose the number 1, that we will receive the same signal. So this is us defining the group of the radio signal. Next, we are going to define some basics or conditions for on button A pressed. We used this before. Our output will basically be radio send number 1. Okay, and then we are going to duplicate this. Right click and choose duplicate. B, you will choose 2. And then when you duplicate it again, C, you will choose 3. Not C, actually, it's A plus B. So now you have A, B, A plus B, 1, 2, and 3. And this is all you need to do for the first microbit. So it transmits a signal, 1 for A, 2 for B, and 3 for A plus B. Let's program the second microbit, and this could be a bit confusing, so please make sure that you're focused. First, we are going to click, of course, on start, and then we are going for radio set group. One. So now both of them are within the same group. Okay. Let us begin with the programming of the servo motors. We will start with on radio received number. We can go to input. We will start with on radio received number value. Okay, and we will start putting several if conditions inside. We will start with the first if condition, which is if true then, and then we'll go to math equal to. So what I'm saying right here is if this value, let me zoom in a bit to show you, is equal to this value, then we will do something. what are the values we're talking about? The first value is actually a variable that we already defined over here, which is value. If it's equal to 1, and we already know what 1 is, it's when you click on A, we will do the following. We will rotate the servo on pen. So we will rotate the servo on pen P2 to 90. And this is the servo that is connected to P2, as you can see. Then we will just add some delay for 1 second. All within the if condition. So make sure you don't put it outside, it has to be inside. And then again, rotate. The same P2 to 0. Okay? And then you wait for 1 second again. Okay. After that, we will start moving the other servo motor. So again, rotate. Also inside, everything is inside the statement so far. We will move the second one, the left leg B, to 90, and then wait. Then again move the servo pen inside, everything is inside the F statement. 8 will go back to 0. So if we click on A, these two motors should be moving 90 to 0. First it will wait and then 0, and then the second one will go to 90, then 0. Now, how about we do the same thing for the when we click on B. I'm just gonna click on F, right click and duplicate, and put it right under the first F. So to make sure it's not inside, it has to be under. And let's move down. So now we're gonna change the value to 2. These two motors are connected to 4 and 16. Let us make sure that this is connected to 16. There we go. They are connected to 14 and 16. Get back to the code. So we will change the pins accordingly. First, you will go to pin 16 to 90, pin 16 to 0, then pin 14 to 90, pin 14 to 0. Okay, so now we moved it according to A alone, B alone. Now what we have to do is just add another if statement for AB. We can just duplicate this again, put it under the second if condition, and put it as 3. Now we will start with, rotate servo on pin. We will start with the very first thing we did at the beginning, which is pin 2. Over here to 90 degrees, and then you wait for 1 second, then rotate servo on pin 2 again to 0, and then again we are repeating ourselves, 8 to 90, 8 to 0, and we can add a wait for 1 second, and then we can just repeat this part, which is the servo pin of 16 and 14. Let us duplicate it. We'll put it aside, and then I'm gonna put it under the weight. So I have P2 to 0, P2 to 90 first, then to 0, P8 to 90, then to 0, P16 to 90, then to 0, and P14 to 90, then to 0. It has to be the same for you. Make sure all of the whole thing is in order and everything is within its own F condition, because otherwise it will be very difficult for you to follow up. Okay, now I am going to add the same code to the motor. Here, if I click on the motor, you will see that it is the same code for here as well, because it is controlled by the microbit. Okay, now let us see what happens when we start simulating. I'm just going to zoom out a bit. We start simulation. Okay, we can move this to the side, and we can move this to the side. Let us click on A. You can see left leg A is moving, and then left leg B is moving. So 90 degrees 0, 90 degrees 0. Let us click on B. 90 degrees 0, 90 degrees 0. Let us click on AB together. The whole thing starts moving. Okay, so make sure, of course, to share your project using the link provided. And for the special mission for today, you need to show or to display robot is moving on the microbit when the motors are moving, and you need to add, when you click on shake, an arrow that shows that the robot is moving. So two special missions. One is to write robot is moving, and the second is whenever you click on shake, there will be an arrow that shows the robot is moving.